Okay, today we're going to be solving radical equations. There's going to be a lot of skills in here that you already know how to do. We're just going to add like one extra little tool to your toolbox, okay? So the first thing I want to ask you is this, okay? If I have x squared equals 25, how would I solve that? What would I need to do?
Square root of 25.
Yeah, because the opposite of x squared is the square root of 25, right? So the square root of 25. X equals, now this is going to come into play later, but this is 5, but it could also be negative 5, okay? So that's going to be something we're going to talk about later, but the square root undoes squared, right? Okay, what if it was cubed? Like x cubed equals 8. How would I undo that? The cube root. Yeah, you're exactly right, Aiden. I would do the cube root of x. What I do on the left, I do on the right. So what I'm saying is that this part cancels out this part. So now we just have x equals the cube root of 8 is 2. Okay, if it's an odd index, we don't have the plus or minus. If it's an even index, we do. Okay? So that's where we're going to today. All right, we're going to start out with our steps. Okay, steps help. Some of us are very linear thinkers. So these are the steps to solving this. Okay, a radical equation has a variable in a radicand. When solving a radical equation, the result may be an extraneous solution. We'll talk about that more probably tomorrow. Right? Step 1 is isolate the radical. Just like when we do basic algebra and we have 4 plus x equals 8, we want to get the x by itself. So what's the opposite of addition? Subtraction. What's the opposite of multiplication? Division. We're going to be using those inverse operations today, just like we've done for years.
Wait, which box? You just wrote this in this box.
Where it says step 1.
Sorry.
I don't care which one there.
I didn't know.
Yeah, let's just format it. 3, 2, 1. Okay, so to undo a whole number exponent, we're going to take the nth root of both right. So that's what we just talked about with this, okay? If it's an even root, we need to have a plus or minus. I'm going to give you an example of that in a minute. Okay, if it's an odd root, you keep the sign. All right, so an example here is if it's an even root. So let's say that we have, like we said, x squared equals 64. We're going to take the square root of that. So the nth root, our index, matches our exponent, right? So x equals, but we would have to do plus or minus 8 because we have an even root. Okay, if it's an odd root, let's do the cubed root of 64. Oops, sorry. We're going to do x cubed equals 64. So to undo that, I do the cubed root. Again, I want my index to match my exponent. What I do on the left, I do on the right. So the cube root of 64 is 4. So this one is just x equals 4. We don't need the plus or minus side. If that was negative 64 inside my radical here, then my only answer would be negative 4. Okay, we good with that? How those negatives impact things and how the odd and even index impacts it? Okay, so this is where we're going to start. So we've got 1/4 x to the 4th. Now, one thing, Owen asked a really good question earlier. He said, well, isn't 1/4 x to the 4th just 1? This is different than if it was x to the 4th to the power of 1/4. Okay, if we had this, if we had x to the 4th to the power of 1/4, this would just be x, right? Because these we would multiply, it'd be 4 over 4. But this is different because it's 1/4 of, okay? So what's my first step going to be here?
Minus 2.
Yeah, we're going to subtract 2. Minus 2, minus 2. 2's cancel out. I've got 1/4 x to the 4th equals 4. Okay, now we're multiplying by a fraction here. This can sometimes be a bit of a speed bump. To undo that, I multiply by the reciprocal. because I want those to cancel out like that. What I do on the left, I do on the right. So I'm going to multiply by 4 over 1. So that's going to give me 16. So I have x to the 4th equals 16. Now we get to use our new tool. So if I want to eliminate that power of 4, what do I need to do?
How do you get side? Whatever it's called, the other side.
I need to find the 4th root of both sides. So I'm going to go like this. The 4th root of x to the 4th. So then these cancel out. So we just have x equals the 4th root of 16. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So I know it's 2, but I have to remember that I have an even exponent, right? So it's got to be what?
Plus or minus.
It's got to be plus or minus 2. Okay, this one's a little bit different because we have a whole, more than just an x squared, right? So what we're trying to do when we're isolating is we want to isolate the whole thing that's being squared. In this case, that whole value of x plus 2 is being squared. So I want to try to get that all by itself. So our goal is to get x plus 2 squared all by itself on the left. So I need to get rid of that minus 5 and that times 2. Some of us, our initial thought is going to be to distribute the 2. Don't. Okay? Don't do that. Because we have an exponent right here. Exponents come before multiplication in our order of operations. We've got to deal with that thing first. Okay? We cannot just go distributing the 2. So I want to undo this first, though. So we're going to add 5 to both sides. Just like that. So then I have 2 times x plus 2. I still have that squared equals 13. Not 13, 18. Okay, now what operation's happening right here between the two? Yeah, that's multiplication. How do I undo multiplication? Division. So I'm going to divide this whole side by 2 so that those cancel out. What I do on the left, I do on the right. So now I'm left with x plus 2 squared equals 9. Okay.
If I got x4, because I went ahead a little bit, if I got x4 plus 8 equals 18, is that wrong? Because I just distributed it out?
Let's see if you get the same answer. Okay. All right, my next step is I want to get rid of this squared. So I need to do what to both sides? I'm going to square root both sides. So we're going to do the square root of, that's going to cancel out our exponent. So we have x plus 2 equals, what's the square root of 9?
3.
Not just 3. It's plus or minus 3. Okay, this is where we've got to take another step. Because it can be plus or minus 3, I can't just solve this as is. I can't just say minus 2, x is 1. That's going to be one of your solutions, but that's not the only one. So what we have to do is break this apart. And on the left, we're going to say x plus 2 equals positive 3. And on the right, we're going to say x plus 2 equals the other option, which is negative 3. So then if I subtract 2 on both sides, I'm going to get that x equals 1, like we talked about. But I'm also going to get x equals negative 5. So x could equal 1, x could equal negative 5. Do we understand what we did there when we went from the red to the green to the orange? Okay, we had to split it up because we have that even index. It's a plus or minus 3. So I had to create 2 separate equations. It's similar to what we do when we're dealing with absolute value equations, right? Okay, now this isn't in your notes. It's just something we're going to look at together. All right, so the term on the left is what we get. What we're going to show on the right is how we cancel that out. So if I'm talking about the square root of x, How do I cancel out the square root? I take it to the power of what? 2, and that's going to leave me with what? Just x. Okay? For the next one, if I'm the cube root of x, I have to take it to the power of 3, and that's going to give me just x. This one I would take to the power of 4, and that would give me just x. And then this one I would take to the power of, whoa. It's not a number. So I take it to the power of what? N. Take it to the power of n, because that's still going to cancel out our index, equals, and that would just give me an x. So that's just a quick little example of how we would cancel that stuff out. Okay? What do you think we're going to do with this? Now we're kind of working the other way.
Do 5.
Not times it by 5. We're going to take it to the power of 5 is how we would say that. Because that power of 5 undoes the fifth root. So what I do on the left, I do on the... Okay, everybody look up and see how I do this. This is important. It's kind of a small thing. I'm going to put this in parentheses and put a 5 here. Okay? Because that is different than that. Okay, those are two different things. The one on the right, now in this case, because we have an odd exponent, we would end up getting the same solution, but it is not the same. We want to think about that inside parentheses. If it was an even, it would mess us up. So this is actually -2 times -2 times -2 times -2, right? So it's a negative times a negative times a negative times a negative times a negative. It's 5 negatives, right? So am I going to end up with a negative or a positive? A negative because it's an odd number. Okay, and then 2 times 2 times 2 times 2 times 2 is 32. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. Any questions on how we get that one? Okay, this one's the simplest one on the page. So I want you to do this one on your own. Remember what the index is on there. I'll show you in a second. I'll show you another example of that. What's the index on this? What number is right here? A 2. So how do I want to undo that 2? I take it to the power of what? 2. So that's going to leave me with x. What would I do on the left? I have to do on the right. So this is to the power of 2. 4 times 4 is 16. That's it. Okay. In this case, it's not going to be plus or minus because we're going the opposite direction. Okay. We have to just look at this. This is positive 4, right? 4 times 4 is always 16. There is no world where 4 times 4 is going to be negative 16, ever. Okay? Now, somebody was asking about the negative thing I alluded to over here in the green one, okay? So I want to show you this. If we do this, and I'm going to use 2, but I do -2 to the 4th, and it's an even exponent. What that right there actually is, like that, is 2 times 2 times 2 times 2 with a negative out in front. So that's going to be -16. Okay? If we do -2 in parentheses to the 4th, that's going to be -2 times -2 times -2 times -2, which is actually going to give me what? A positive 16, right? That's why the parentheses matter there. They matter more when you have an even exponent. When they have an odd exponent, they're not really going to play a role. You just kind of get lucky. But you need to make sure that you know what that means. Okay, let's do the third one. Don't overcomplicate this one. How do we undo the cube root of? Take it to the power of what? 3. What I do on the left, I do on the Okay, this is what we learned the other day. That 3 applies to the 1 and the 2. So we have x equals, what's 1 cubed? 1 times 1 times 1 is 1. What's 2 cubed? 8. That's it. So there's your 3 examples. We're going to do one more in class today. Okay? You excited about that? Yeah. You're thrilled. Good. Here we go. Go. See what you would do. What's my first step going to be, Taraji? Minus the 2, because we have to isolate the what? Starts with an R and rhymes with particle. Got to isolate the radical. So now we have 3x minus 5 underneath our radical equals 4. Now I got to get rid of that radical, right? Emma, what am I going to do? Take it to the power of 2. What I do on the left, I do on the right. So now I have 3x minus 5 equals 16. Now this becomes middle school math, right? Add 5, 3x equals 21, divide by 3, x equals 7. Okay, now one thing we need to make sure that we do is plug in our solutions. And we're going to talk more about this tomorrow, okay? But I'm going to take this 7 and plug it back in here, okay? So stay with me. What is 3 times 7? 21. So I've got the square root of 21 minus 5 plus 2. And this should equal 6, okay? So what's 21 minus 5? 16. Okay, so now we have the square root of 16 plus 2 equals 6. What's the square root of 16? 4, right? Is 4 plus 2 6? Then we're good. Check mark. Star. Smiley face. Highlight. Woo, that's a right answer. Okay, sometimes when we do this with radicals, we're going to get numbers that don't work. Those are called extraneous solutions. We're going to deal with that tomorrow. Okay?